Question 1 tutorial 10. In this question, we have two water reservoirs A and B. We have A and B are connected to each other through 4 meter long. This one is 4 meter long pipe and 2 centimeter diameter cast iron pipe. This one is the material. Okay, so from the material you have the roughness E with the sharp edge entrance. We have a sharp edge entrance. It means from this one we have a one minor energy loss. We have KL1. Sorry, we have here we have KL1 is sharp edge entrance. The pipe also involves a swing check span. This one we have a swing check span. This means we will have another energy loss, minor loss, KL2 for swing check span. Okay, and we have a fully open gas van. This one is fully open gas van, so we have KL3. And at the exit of this pipe, we have KL4. Okay, exit. And the water level in both reservoirs is the same, but the reservoir A is pressurized by compressed air, while the reservoir B is open to the atmosphere with pressure P2 equal to atmospheric pressure equal to 88 kPa. Okay. If the initial flow rate through the pipe is 1.2, this one is volume flow rate, 1.2 liters per second, you find the absolute air pressure on the top of reservoir A, P1. Okay, take the water temperature is 10. Okay, so now how to find pressure? In internal flow, we have three equations: mass conservation, we have energy equation, and momentum equation. Okay, in this question, we don't have force, no momentum equation. Okay, in the mass conservation, we don't have pressure in the mass conservation, so just only energy equation. Okay, so to find P1, it means to find P1, you have to apply the energy equation. And to write the energy equation, we have to choose 2 points. In this case, we will choose point 1 and point 2 on the water surface, because for point 1 and point 2 on the water surface, we will have V1 velocity equal to V2 equal to 0. Okay, and moreover, we have Z1 will be equal to Z2 because the water level in both reservoirs is the same. Z1 will be equal to Z2 is 0. Okay, so we will write the energy equation between point 1 and point 2 to write P1. Energy equation between point 1 and point 2. Point 1, P1 over rho Z, V1 square over 2Z. That's one. No pump. Okay, so that's finished in the left hand side. In the right hand side, P2 over rho Z, V2 square over 2Z. Z2 is energy point 2, and SL is energy loss. Because we have Z1 equal to Z2, so we can cancel out this one. Z1, Z2. Okay. We have V1 equal to V2 is 0. On the water surface is 0. P2 we have here is 88 kPa or 88,000 Pascal. Density is 1,000 kilogram per meter cube. Okay, gravity is 9.81. P1, we have to find P1. I call this one equation 1. Okay, so if you have looked in the equation 1, to find P1, you have to know SL. SL is the heat loss. Okay, and SL equal to major loss and minor loss. With major is friction loss is F L over D V square over 2Z. Minor loss is sigma KL V square over 2Z. Okay, sigma KL is sigma loss coefficient, or equal to F L over D plus sigma KL V square over 2Z. Okay, this one I call is equation 2. Now let's have a look in the equation 2. Velocity, that's easy. Velocity equal to volume flow rate divided by cross-section area. This one you have. With volume flow rate you have is 1.2 liters per second or 0.0012 meter cube per second, converts to SI units, divided by pi, the diameter is 2, so 0.02 square over 4. So the velocity in this case you have here is 3.82 meters per second. Okay, so velocity, that's easy. We have L. L, the length is 40 meters is given. The diameter is 0.02 meter. Okay, so to find SL, you have to know F and sigma KL. F is friction coefficient F, and friction coefficient F. To find F, you have to know E over D and Reynolds number. E over D for cast iron. For cast iron, you have table 8.11. Cast iron, okay, we have cast iron, the roughness is 0.26 millimeter. Okay, you have here is 0.26 millimeter. The diameter is 2 centimeter or 20 millimeter. So E over D is 0.013. Okay, 0.013 E over D. Reynolds number equal to rho V D over mu. With rho is 1000. Velocity is 3.82. D, the diameter is 0.02. Viscosity, in this question we have water temperature is 10 Celsius, so we have to find viscosity of water at 10 Celsius. We have table 8.3. Okay, table 8.3. We have at 10 Celsius, we have viscosity is 1.307 times 10 minus 3. Okay, we have 1.307 times 10 minus 3. So we will have Reynolds number here is 58,400. Okay, so now from E over D and Reynolds number based on Moody, you can find F. Now we will have a look in the Moody diagram. Okay, this one is the Moody diagram, and we have E over D is 0.013. We have here is 0.01, 0.015, so 0.013 will be here. We draw a curve as 0.013. Here is 0.013, and the Reynolds number is approximately 5.8 10 power 4. We have 10 power 4 here. 5.8 will be this one. So we have a ruler, and we draw, and it's cut this curve in this point. this point. Okay, so in this case F is approximately 0.042. We have here F is approximately is 0.042 from Moody diagram. Okay, so now when you have F you have already, so now it's sigma KL. With sigma KL, as I said, we have 4 minor loss equal to KL1. KL1 is as the entrance, KL2 is for swing check span, KL3 is a fully open gate span, and KL4 for the exit. Okay, so now for KL, you can use a lecture slide, lecture week 10. Week 10 lecture slide. We have first one, we have engines and engines. Okay, we have SAP X engines, KL is 0.5 or KL1 you have is 0.5. Okay, it's for the van. Here this one. Okay, so we have swing check span, KL2 is 2 plus 2. KL3 for fully open gate span, KL is 0.2. 0.2. Okay, so KL4 for the exit. Okay, for the exit we use this one. We have for the exit, and because the Reynolds number is more than 58,000. Okay, so the fluid flow will be is turbulent. For turbulent flow, you have KL is 1.05. 1.05. Okay, you see here. For it's 2 for fully for laminar flow and 1.05 for turbulent flow. So sigma KL will be 3.75. Okay, now we apply F and sigma KL in equation 2. We will have equation F. We have SL will be is F is 0.042. L will be is 40. However, the diameter is 0.02. Okay, plus sigma KL 3.75. V is 3.82 times 3.82 square over 2 times 9.81. Okay, so SL is approximately 65.8 meter. Okay, so now when you have SL based on equation 1, okay, in equation 1 you will have, when you move rho z to the right hand side, you will have P1 equal to P2 plus rho z SL, or equal to P2 is 88,000 plus rho is 1,000, 9.81, 65.8. Okay, so this one is approximately 733,000 Pascal or 733 kPa. The pressure is 0.1. Thank you.